So welcome back. We're going to carry on with our study of geometric sequences, and let's take a look at those questions we asked you to do in the last lesson and see how you went with them. Okay, so first up, let's remind ourselves of the formula. Tn is A times by R, the common ratio to the power n minus 1. Okay, so this one, remember there are four variables in here. There's A, there's R, there's N, and there's the term. This one we are told that T5 is 1,25. So we're going to put 1,25 here. We're told that A is 20. And we don't know R, alright? But we do know that N is this. This is the fifth term, so this will be 5 minus 1. Okay, so now what we're going to do is we're going to go 1,25 over 20. And that's going to give us R to the 4. Right, now what we're going to do next is we're going to raise, remember the idea of a set of scales? We're going to do the same thing to both sides. We're going to raise both sides to the power of a quarter. And I just want to show you what this actually looks like. It all is connected to everything else, because if we have an exponent raised to an exponent, a power raised to a power, then what happens is that they will multiply. So we actually want a power here that's going to multiply with 4 over 1 to give us 1. And the answer to that is 1 over 4. Alright, this is the same as finding a fourth root. Okay, but if we do that on this side, we must do the same on this side. 1 over 4. Okay, so now we will get what R is equal to. We do just need to be a little bit careful, because when we have an even power, we can actually have a plus or a minus answer here. So let's just have a look at what all this comes to. Alright, so what we've got is we've got 1,25 over 20. Let's put all that in brackets. 1,25 over 20. Let's go over there and close that bracket. And we're going to raise that to the power of a quarter. 1 over 4. Okay, and we get a half. Alright, nice, neat, tidy answer. But remember, because it was an even power, we can have plus or minus a half. Now there are going to be two different possibilities for our first three terms. We could have 20, and obviously if R is a half, A is 20, R is a half, we're going to get 10, and then we're going to get 5. All right. The next one would be 2.5, and the next one, the fifth one, would be 1.25. All right. But the other possibility for the first three terms, all right, is that we get 20. And then if we multiply by negative a half, we're going to get negative 10. But then we're still going to, when we multiply by negative a half, we're still going to get positive 5. And you'll see that obviously here we would get negative 2.5 as our next term. But then again, we would get positive 1.25. Okay, so there are actually two possible answers there. Right. Let's Penduli Ikasi, let's move on to the next one, number 18. All right. Now at the moment, and we're going to learn later this term, we're going to learn a new function that's going to allow us to solve for exponents. But at the moment, we're going to have to sort of do this by trial and error. How many terms are there in this sequence? So remember our formula, Tn is A, R to the n minus 1. All right, what is R? R is any term divided by the term before it. So R is in fact 3. It's either 3 over 1, 3 divided by 1, or 9 divided by 3. So we know that R is 3. We want to find out what term number, which one is equal to 729. So what we're going to do is we're going to put 729 here. That's the actual term. All right. A we know is 1. And now to the n minus 1. Right. Now, what we're going to have to do for here is we have to just trial and error it, okay? So let's try putting 3 to the 5, for example, into our calculator and see what we get. Well, maybe 3 to the 5 is too good a guess. Let's try 3 to the 6. All right. 3 to the 6 is actually 729. All right. So it's a great first guess, but otherwise, what you can also do, depending on which calculator you've got, you could try and prime factorize this by going 7 to 9 equals, and then go shift fact, and then we see 729 is actually 3 to the 6. So now what we've got 3 to the 6 is 3 to the n minus 1. Because the bases are the same, the exponents must be the same. So 6 is n minus 1, and so in fact n is 7. Okay, right. We hope you tried number 19 as well, so we will go over that one. All right. Is this thing a term in the sequence? Okay, and let's see if we can have a look at this. Once again, let's write down our formula. Tn is a r to the n minus 1. And so 8194 is a, it's 2, times r. R is any term divided by the term before it. R is also 2, and this is going to the n minus 1. Now we're trying to solve this equation, okay? There's actually two things we could do here. We could multiply these two bases and get 2, because remember this is 2 to the 1, okay? Or we could divide both sides by 2 first. Let's just multiply those two things. Remember, when we multiply numbers with the same base, we add the exponents. So 2 to the n is 8194. Now what we need to establish is, can we make 8194 as powers of 2? Let's just try a few. So if we go 2 to the 8, 2 to the power of 8, let's see what we get. Okay, we get that. So let's try going 2 to the power of, say, 10, and we get that. So let's try going a little bit bigger. Let's try going 2 to the 13. All right, now 2 to the 13, we get 8192. That's very, very close. So the 13th term would be 8192. We're not going to get 8194. Okay, so no, all right, it's not in the sequence. Okay, this will become a bit easier once we've studied logs, all right, where we can actually solve directly for this number, but we will get to that in our next module. Okay. Right, now this next one does not involve, in fact, neither of the next two, neither of them involves the formula at all. I'm going to remind you of this, okay? And once again, you're going to think, well, what's happening here? But if we've got sort of triangle, lightning bolt, and then maybe ball, and we tell you that they are in geometric progression, so in other words, they form a geometric sequence, then clearly this divided by this must be the same as what? It must be the same as ball divided by lightning bolt. Maths is just about symbols, okay? All right, so over here, if 3a and 48 are consecutive terms of a sequence, then what we know is that a divided by 3 is the same as 48 divided by a. Okay, now, a big idea, which I'm just going to show you, is that if you've got two fractions equal, you've got an equation, then the top of the one multiplied by the bottom of the other will be the same as the top of this one multiplied by the bottom of that one. It's just a quick way of clearing fractions. Let's just see what we're saying. We're saying that a squared will be 148, it will be 48 times 3. 48 times 3 is 144. All right, now notice how we've quickly got rid of the fractions. I'm just going to spend a minute or two on this as to why this is the case. Okay, or let's just firstly do another numerical example. If I asked you to give me an equivalent fraction to 4/10, I'm hoping that all of you would be able to simplify that down, and you might say it's 2/5. There are other equivalent fractions to 4/10, like 40 over 100, or even 12 over 30, all right? But let's just go with that for now. And what I just want us to observe first is that if we multiply that by that, we get 20, and if we multiply that by that, we get 20. Now this is not magic. This is not kind of some sort of voodoo thing. Let's think about this equation of a over b equals c over d. In other words, two fractions equal to one another. If I wanted to get rid of the fraction here of dividing by b, what should I do to both sides to get rid of the fraction? That's right, I would multiply both sides by b. So now I'm multiplying this by b, and remember the b's on the top, it's b over 1. So I get bc over d. Right. Now I've still got a fraction. what should I multiply both sides by to get rid of the fraction on the right-hand side? All right, we're dividing by d. The undoing of dividing by d is to multiply by d on which side? Absolutely, on both sides. All right, when I multiply by d on both sides, I get AD equals BC. And if you look at what that's saying, it's saying that this times this is equal to that times that. All right, that was quite a long sort of interlude, but let's now finish this off. Now, when we square root here, because it's an even power, remember we can have plus or minus 12. Okay, and that's our answer. It just asks us to find the possible value or values of A. There are two. All right, just to close it out and to show you that if A was 12, then our sequence would be 3 times 12 is 36, and 36 times 12, so I'm just trying to look at this. Sorry, if A was 12, sorry guys, going quietly mad here. Not R. R is not 12. If A is 12, is this an geometric sequence? Yes. What are we actually multiplying by? Sorry guys. Too early in the morning, all right? If A is 12, what's our common ratio? Yes, our common ratio is just 4. It's 12 divided by 3 or 48 divided by 12. But also if A is negative 12, these are also a geometric sequence because now this divided by this is negative 4 and so is this divided by this negative 4. In this one, R is 4 and in this one, R is negative 4. Okay, right, let's pause the video. We want you to try the next one, which is very similar. Okay, have a go at it. Okay, so exactly the same idea. We've got P plus 3 divided by P plus 1. And that must be exactly the same as 3P plus 5 divided by P plus 3. Right, now, the quick way that we learn to get rid of the fractions, P plus 3 all squared. And here we're going to get 3P plus 5 multiplied by P plus 1. Okay, now, Giyasaba, mind you, I'm worried that people are going to say P squared plus 9. If I had 1 rand, Ellie Lord, 1 rand for every time I saw that, I would be a millionaire. If I was a millionaire, you know what I would do? Well, I'd carry on teaching you guys maths because that's what I love to do. Okay, squaring a binomial is something that we're going to do very, very often. If you're not sure, write them out next to each other. But I'm going to just take a little break and go onto the side here. And I'm just going to remind you that if you square A plus B, what that means is you're going to multiply A plus B by another A plus B. Now, everything in the left-hand bracket must multiply by everything in the right-hand bracket. So we're going to get an A times an A. We're going to get an A times a B over here and an A times a B over here. We're actually going to get 2 lots of AB. And lastly, at the end, we're going to get B squared. That is the answer to this, okay? Now, I want to just try and see if we can sort of generalize this. If we look here, sorry. We look here at this 2. This 2 is because we get the same product from the outers and the inners, okay? And when we use FOIL, if you use FOIL, all right. Now, let's have a look. What would fish plus triangle squared be? Well, let's look at the pattern. It would just be fish squared plus 2 times triangle times fish. And it doesn't matter whether we say triangle fish or fish triangle because that's the same. We can multiply numbers in any order. 3 7s are 21. 7 3s are 21. And then triangle squared. Okay, right. So because we're going to need to square binomials very often, it's worth being able to do this straight away correctly. P squared plus 6p. That 6p is 3p. That times 2, 6p, plus 9. On the right-hand side, we've got 3p squared. We've got 5p, and we've got 3p. We've actually got 8p, and then we've got plus 5. Okay, this is a quadratic equation, but let's get everything on one side. Let's subtract p squared from both sides. Remember the scales. Let's subtract 6p from both sides, and we get 2p. And let's subtract 9 from both sides, and we get minus 4. Now, let's divide both sides by 2, and we get p squared plus 2p, sorry, not plus 2p, plus 1p, we're dividing by 2, minus 2. Right, now this can factorize. This might be something that you don't necessarily remember all that well, but this can factorize to p and p. Now, if we think about it, the only way we can get a negative product is to have one positive thing, all right, multiplying with a negative thing. So our signs are going to be different, 1 plus 1 minus, and we want factors of 2. And in fact, there are only 2 factors of 2, and those are 2 and 1. We want to end up with a positive number of p's, so the bigger number, the 2, will go over here, and the 1 will go over there. We've now got our answers. P is negative 2, or p is 1. Okay, and let's just take a look up at the top here. That's the answer. But let's just take a look as a sort of check. If p is 1, then our terms are going to be 2. If p is 1, we're going to get 1 plus 3. We're going to get 4. And if p is 1, we're going to get 3 lots of 1, which is 3, plus 5, we're going to get 8. Is that geometric? Yes, it is. R is 2. Okay, now let's have a look. If p is in fact negative 2, negative 2 plus 1, negative 2 plus 1, negative 1. Negative 2 plus 3, positive 1. Negative 2 times 3 times negative 2, negative 6, plus 5, negative 1. Now, you may be saying, is that geometric? Yes, it is. In this one, r would actually be negative 1. The numbers aren't changing, the signs are just changing. All right, whereas in this one, r is 2. What I've done up here is just check my answer. You don't have to do that, but it does give you a kind of a nice, warm, fuzzy feeling inside knowing that you've got it right. Okay, let's do one involving simultaneous equations, just like we did last time. All right, so remember our formula, Tn equals AR to the n minus 1. How do I know I'm using this formula? Because the question says we've got a geometric sequence. Okay, so let's put this piece of information into here. And so I'm going to do it like I did last time. I'm going to sort of color code it. I'm going to do a red equation. 192 equals A times by R to the 7 minus 1. That's an equation. Nansinkinga, there are 2 variables. We need another equation. Let's get a blue equation. All right, T2 is 6. Now, if T2 is 6, then 6 is A times by R to the 2 minus 1. Okay, 2 minus 1, just 1. Okay, and that's equation number 2. Now, with these, because we both have got this multiplication here and we've got the same powers on the a's, if we divide these 2 equations, now remember with arithmetic ones we subtracted them because we had an a plus and an a plus, and that eliminated the a's. If we divide them, so we're going to go equation number 1 divided by equation number 2, what we get here, all right, 192 divided by 6 is actually 32. What we get here, the a's divide out, they eliminate, and we get r. Remember our exponent rules? Subtract the powers, we get that. All right. Now, what power should I put onto the right-hand side to get rid of this power of 5? Okay, 1 over 5. If I do that on the right, remember the scales, I must do that on the left. Okay. Now, 32 to the 1 over 5 is actually 2. R equals 2. Okay, now we're not finished. It asks us to give the first 3 terms. How will we find A? Well, once we've got our value for R, we can put that value into either equation. So we're going to sub it in, and that will allow us to find the value for A. So we know that 6 is A multiplied by 2. Very simple little equation. Divide both sides by 2. We know that A equals 3. All right. We're still not finished because they want the first 3 terms. The first 3 terms are very straightforward. All right. Because they're going to be 3. The next one's going to be 3 times 2. It's going to be 6. And the next one's going to be 6 times 2. It's going to be 12. Okay. We're going to stop there. We're going to ask you to try number 23 before we start the next video. So have a go and see how you go. Ubinosuku oluhle.